Trigonometry by Sophia. Let's start with SOHCAHTOA, which is simply an easy way to find side lengths and angles of a right triangle. Let's break down SOHCAHTOA. So means sine equals opposite over hypotenuse. Ka means cosine equals adjacent over hypotenuse. And toa means tangent equals opposite over adjacent. Let's see a couple examples of this. Solve for side length DE. So let's start off by choosing which trig function we are going to use. We are given angle F, which is 30 degrees, the hypotenuse, and we need to find the side lengths opposite to angle F. The only function with opposite and hypotenuse is sine. So, plugging in what we know, we get sine of 30 degrees is equal to d over 10. Multiply each side by 10 to get DE alone, then multiply 10 times sine of 30 to get your answer 5. That came out nice and easy. On to the next example. Find the side length, HG. We want to use the same idea. We are given the angle G, which is 33 degrees, and the hypotenuse, and we are trying to find the side length adjacent to 33 degrees. Therefore, we use cosine. Setting up our equation, we have cosine of 33 equals HG over 6. Multiply each side by 6, then multiply 6 times sine of 33. Round your answer to the hundreds and you should get 5.03. Next we will learn about inverse trig functions. This is when you take the inverse, or opposite, of the functions sine, cosine, and/or tangent. You are simply undoing these functions. Arcsine undoes sine. Arccosine undoes cosine. Arctangent undoes tangent, and so on. You still use SOHCAHTOA, but your operation will involve an inverse trig function. Let's do a couple of problems. First, solve for theta. Using SOHCAHTOA, we can see we need to use cosine, so our equation looks like cosine of theta equals 2 over 4. Now, in order to get that alone, we need to take the arccosine of each side, which will get us 60 degrees. Pretty easy. The next problem also asks us to find theta. Using SOHCAHTOA, we use the function tangent, and our equation should look like tangent of theta equals 6 over 2. Take the arctangent of both sides to get theta alone, and your final answer should be 71.57 degrees. Next up, we have the law of cosines. Like SOHCAHTOA, law of cosines can be used to find side lengths and angles of triangles, but you use this law of cosines when said triangle is not right. The formula for the law of cosines is c squared equals a squared plus b squared minus 2ab times cos of c. So let's break down how we get that equation. To develop the law of cosines, begin with triangle ABC to the right. From vertex C, draw altitude k, which separates side C into segments x and c minus x. Now triangle ABC has been split into two right triangles. We will use Pythagorean theorem to write two equations, one relating k, b, and c minus x, and another relating a, k, and x. The first equation is c minus x squared plus k squared equals b squared, and the second is x squared plus k squared equals a squared. Notice that both of these equations contain k squared, so now let's solve each equation for k squared. The first one looks like k squared equals b squared minus c squared c. The first one now looks like k squared equals b squared minus c minus x squared, and the second equation looks like k squared equals a squared minus x squared. Now that both equations are equal to k squared, we can set them equal to one another. Our new equation is b squared minus c minus x squared is equal to a squared minus x squared. Since this equation still has an x, we will expand c minus x squared to c squared minus 2cx plus x squared. Then plug this in to get the new equation b squared minus c squared minus 2cx plus x squared is equal to a squared minus x squared. Solve this equation for b squared to get b squared equals a squared plus c squared minus 2cx. This equation also still involves x, so let's use cosine to cancel this x out. So we have cosine of b equals x over a. Solve this for a to get x equals a times cos of b. Plug this in to get our formula b squared equals a squared plus c squared minus 2ca times cos of b. Let's do some practice on this. First off, we have an easy problem. Find the length of b. So let's plug in what we have to our equation to get b squared equals 10 squared, which is 100, plus 11 squared, which is 121, minus 220 times the cosine of 46. 220 times the cosine of 46 is 152 minus 82, and 221 minus that is 68.18. Square root both sides to get rid of squared b, and your answer is 8.3. Now let's do a hard problem. Find the measure of angle b. Well, we have all three side lengths, 6, 13, and 15, so let's plug these into our equation. 13 squared, which is 169, is equal to 15 squared, which is 225, plus 6 squared, which is 36, minus 180 times the cosine of b. Let's subtract 261 to the other side, getting negative 92, which is equal to negative 180 times cosine of b. Divide negative 180 to the other side, getting 92 over 180 is equal to cos of b. Then take the inverse of cosine to both sides, and your answer should be 59.3 degrees. Now let's learn about law of sines. Use the law of sines when you are trying to find ratios between numbers. In order to use the law of sines, you need to know either two angles in one side of the triangle or two sides in an angle opposite one of them. While law of cosines only applied to non-right triangles, law of sines applies to all triangles. No bias here. The formula for the law of sines is sine of A over A is equal to sine of B over B equals sine of C over C. So let's break this equation down. Look at triangle ABC to the right. Let's draw altitude K from vertex B. This creates two right triangles in triangle ABC. Let's write two equations involving angle A and angle C. These two equations are sine of A equals K over C and sine of C equals K over A. Solve each equation for K, getting K equals C times sine of A and K equals A times sine of C. Now both equations can be set equal to each other, getting A times sine of C equals C times sine of A. Regroup A with sine of A and C with sine of C, getting sine of C over C is equal to sine of A over A. Now let's draw a new altitude K from vertex C. We now have two right triangles in ABC. So let's write two equations, one involving sine of A and one involving sine of B. So our equations are sine of A equals K over B and sine of B equals K over A. Notice that each of these equations involve K. Let's solve each equation for K. Our new equations are B times sine of A equals K and A times sine of B equals K. Since both equations are equal to K, they can be set equal to each other. Now we have B times sine of A equals A times sine of B. Same as before, let's regroup A with sine of A and B with sine of B, getting sine of A over A equals sine of B over B. Now everything can be set equal to each other, getting sine of A over A is equal to sine of B over B equals sine of C over C, which is our formula. Let's do an easy example on this. Find the length of side C. Since we have angle A, side length A, and angle C, we can use the formula sine of A over A equals sine of C over C. Plugging everything in, we should get sine of 33 over 5 is equal to sine of 67 over C. Multiply this out, and you get C times sine of 33 is equal to 4.6. Divide by sine of 33, which is 0.54 on each side, and get your answer 8.5. On to a harder problem. Find the measure of angle C. We have both the angle and the side length of A and the side length of C, so we can set A equal to C. Plug in our information to the equation to get sine of 73 over 12 is equal to sine of C over 11. Cross multiply, getting 10.52 is equal to 12 times sine of C. Divide each side by 12, getting sine of C alone, and 0.88 on the other side. Take the arcsine of each side in order to get your final answer, 61 degrees.